We've all learnt in school that matter exists in only three states: solid, liquid, and gas. However, plasma, which exists in the cores of stars, and the lightning you see, can be considered as the fourth state of matter. This was what most scientists in the early 20th century thought too, until Satyendra Bose, an Indian mathematician and physicist, predicted the existence of a fifth state of matter, and with the help of none other than Albert Einstein, he set out to prove this mind-blowing hypothesis of his. This fifth state of matter came to be known as the BoseEinstein condensate, an exotic and rare form of matter. Now, before we dive deeper, we need to know a few things that will help us understand this entity a whole lot better.
Have you heard of quantum superposition? Let me explain. Take the example of a boy holding a butterfly in his hand. There's a 50% chance that he may or may not squish the butterfly on his way home. You won't know whether the butterfly is dead or alive until and unless the boy opens his hand upon reaching his home. Thus, we can say that the butterfly is in a state of superposition. That is, it is both dead and alive the moment before the boy decides to open his hand. However, after he opens his hand, nature is forced to take a decision and the butterfly ends up either dead or alive. This property of existing in two places at once, or even three, immediately before being observed, is also exhibited by atoms.
We all know that particles can exist at only one place at one time, such as this pencil, right? However, sound, as we know, travels as a wave and can exist at multiple places at the same time, just like our atom. So is an atom a wave? Yes, it is. In fact, it behaves as a wave when its position is uncertain, and as a particle when we have observed it and know the exact position of it. Whoa! We have just found out the wave-particle duality of matter. If you really think about it, all matter is made up of atoms, so all of us are made up of waves. And as you would recall from your physics class, the wavelength of an object is inversely proportional to its momentum. This means that the lesser the momentum of an object, the larger the wavelength. How is all of this relevant to understanding the Bose-Einstein condensate? When atoms are cooled to near absolute zero or 0 degrees Kelvin, which is the coldest ever temperature possible in the universe, they lose so much energy that their momentum decreases substantially. Due to this, their wavelengths increase so much that the waves start to overlap each other. When this happens, the atoms can't differentiate between themselves and other atoms, thus losing their identity in the process. The whole thing starts behaving as a single atom, as a single entity, finally becoming what it is meant to be. The Bose-Einstein condensate. Harnessing this could mean the doorway between the known and the unknown. Being sensitive to nearly all forces in the universe, with it we can know more about gravitational waves, build precision instruments, develop the best quantum computers, and most importantly, discover the truth of the universe. Thanks for watching.